Can you guys hear me?
I can hear you now.
Okay. Thank you. Sorry about all this. So let me present again. Okay, so I started trying to write the pseudocode for radix sort. So I said, first thing, look through the array to find the longest length of digits in the items. That length will determine how many iterations would occur later. So now in each iteration, so in each iteration, create an array of 10 buckets. An array of 10 buckets. For these buckets, I'll just put arrays so nobody will be confused. The buckets are actually arrays. Okay. Then, yeah, loop through the entire array and look through the entire array, checking the, should we say, nth digit from the end. Yes. And push each number into the corresponding bucket. Does this make sense to you guys? Look through the entire array, checking the nth digits. So in the first array, you're checking, the last digit from the end, the
I can't
zero.
hear anymore.
What's up with this network now?
Okay.
Can you hear me now?
Yeah, you can.
There's a kind of
Like
lag.
your screen is frozen.
Yeah, there's a bit of lag. Hmm. What does somebody do about all this now? Okay. All right. So I think we're okay. So does this make sense to you guys? Look through the entire array, checking the nth digit from the end, and push each number into the corresponding bucket. So in the first iteration, you will be checking, the first digit from the end. So I guess your n. Look through the entire. Let me see. Well, I think it's still alright to put it. Um, you'll be looping from 1 to n. Longest length of digits in the items. Let me call it n. So you'll be looping from 1 to n. So if n is 1, you're looping from 1 to 1. So now in each iteration, you are checking the nth digit. So since your first iteration, let me say you're using I, like let I equal to 0, I less than n, you are checking the first digit from the end, and then you're using that to place or push each number into the corresponding bucket. So the first time, we're checking this.
Your screen is not showing again.
Oh. Okay, can you guys see my screen? All right.
Yes.
All right, so we're looping through the entire array, checking the nth digit from the end. I made some changes. Loop through the array to find the longest length of digits in the items, n, as in you can call that variable n if you want. So that length will determine how many iterations will occur later. In each iteration, create an array of 10 buckets or arrays, 10 empty arrays. So you'll be looping from 1 to n, not 0 to n, 1 to n.
Hello, please, can you hear me?
I can hear you.
Hello?
I can hear you.
Hello? Yes,
I can hear you, but okay.
Yeah, it seems there's a lag from my end. So when I talk, it takes a while before you guys hear it. Anyway, all is well. So yeah, loop through the entire array, checking the nth digits. So in the first...
Hello, can you hear me?
I can hear you.
Hello? Yes,
No,
yes.
no.
Okay, please, is the way the way the looping is done, sorry.
Yeah.
Checking the first, is it the last digit? Or is it like in case of 243 now, we're checking 2? Or we're checking 3, that's at the end?
The first time we're looping through, we're looking at the nth digit, like, or should I say the ith digit. So the first time we're looping through, I is 1. So we'll be looking at the first digit from the end. That's why 2453 is entering the 3 buckets. 37 is entering the 7 buckets.
Why is it the sorry, the ith digit, and it is entering the 2453 buckets, sorry. Is it the length 1, 2, 3, 4? 0, 1, 2, 3, 1, 2, 3, 4. Is that why it is there? That's what that's just confusing me.
Something like this.
Hello? Did you hear me?
Yeah, I heard you. Something like this. This is what I'm talking about. This is what the for loop will look like. If you are using a for loop, this is what it will look like. Let I is 1. I would always start from 1 and it will stop at n. N is the longest, the length of the longest digits in the array. So each time you are checking the ith digit from the end. So the first, see this first place now.
Okay.
2453 entered the 3 buckets because the first digit from the end is 3. This one is 2. It entered the second bucket. The second time we're looping, I is now 2. So we'll be checking the second digit from the end. So here, 5. That's why it entered 5 bucket. You see, 5, 5. This one is 8. 8, 8. This one is 3. This is 2. So if at any point, the whatever number from the end you are checking happens to not exist, like in the case of 9, if you are on the second turn now, we're checking the second digit from the end, but 9 doesn't have a second digit from the end, you take it as 0 and you put it in the 0 bucket. So after each turn, you concatenate the array. The entire array is beginning from the end.
Okay.
Concatenate all the
Okay, think you understand it.
arrays beginning from or starting from the beginning. Okay, so if you notice, every time we concatenated, let me try and space this out. So this is what the array looked like at first. These were the buckets. You join them together, you get this. Buckets again, join them together, you get this. So you notice we're always concatenating from the beginning. So 9 goes in first, 9, 23, 37. Okay. And after the last loop, at the end of the last loop, whatever was returned, whatever the array you get, that's your final array. You return that. So yeah, that's it for radix sort. It's.
Can I see the final array?
Can you see what?
Can I see the final array?
Final array.
The final array.
Okay, yeah, this is it.
Okay, it doesn't really. It accepted it though.
Yeah, you from the if you're following through, you will see it sourcing itself somehow. From the beginning, 9 already moves to the front. Before you know it, it was joined by 37, 89. Things were still going. 923 is the next. Then 2453, 7252, and this one. And before you know it, it's sorted. So it's just jejely before you know it, everything is sorted. It's a very nice algorithm. But it makes you wonder what somebody was thinking of to create something like this. So, as you can imagine, you would have to create a few helper functions. Something like how to check, the number of digits in a number easily. People can go about it different ways. Like you can turn this to a string and check the length, right? That's a way to know how long a number is, or rather how many digits are in a number. So that also works, sure. But I saw this very nice method. I said, let me share it with you guys. So if you you've heard of logarithm, right? In maths, right? Log, maybe
as a word.
Log 57 in maths. So the thing with log is that it's just trying to find out
log 1.
What power you would raise 10 to that you will get this number. So there is a very interesting thing with log. If you have log of a 1-digit number, the log is always, I think is always less than 1. If you have a log of a 2-digit number, it's always greater than 1 but less than 2. 3-digit number, greater than 2 but less than 3. So you are beginning to follow, Abby. Whatever number of digits you have in a number, if you find the log of that number and floor it and add 1 to it, you will get the number of digits in that number. So let's try an example of that. Math dot log 10, let me say 89. Okay, cool. Yeah, you get this. So if you floor this thing, and add 1 to it at the end of the whole day, add 1, you get 2. If you were to remove this, you get 1. Maybe make this 0. Okay, yeah. in the function for finding, length, digits, the length of digits in a number, you have to add a base case that if the number is 0, it should return 1, because log of 0 is minus infinity. That's the only one that will give trouble. Yeah, but aside from 0, every other number you'll get it correctly. So if we try maybe 37, we get 2. Maybe 7252. 7252. You get 4. You add something to it. So 5. So like that. So that's one helper function. Another thing, is there a second helper function we need? Yes. Another function is needed to be able to get a certain digit, like a particular digit in a number. So like you say, maybe you create a function called get digits, that you pass in a number and pass in a position. So maybe you say get digits 7252 2, and it will return 5, something like that. So you would have to come up with something there. But let me see. So trying to create this now. Does anybody have any ideas? A function, you pass in a number and a position, and it returns the value at that position. Anyway, to save time, if you, for example, if you are looking for the first digit from the end in this number, if you were to divide this number by 10 raised to power 1 and let me see, return norm divide by Hmm? Okay, 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 okay. So this formula takes the first position in a digit as 0, the next one as 1, the next one as 2, the next one as 3, like that. So if you were looking for the first digit in a number, you would pass in, you know, how do I put it? Something would have to change now from, so I guess in this case we can be looping from 0 to n minus 1 to n minus 1, as in less than n. 0 to, like in this case now, it will just be I is less than n. And then anytime we want to find a number, find the digit in a number, you just say that digit and I, or you leave things the way they were. This was, you leave things the way they were, and whenever you want to find a digit, for example, you can say get digits norm and then I minus 1. It's up to you, but I think it will be more straightforward to just do 0 to n minus 1, blah blah blah. So since this array has 10 things, using what you get, using the digit you get here as an index, like let me say buckets, yeah, maybe you could call this array of arrays buckets dot push, you know, okay, buckets square brackets, this one can go in there, something like this. So if this were to return 2, then it will push it into the second item in buckets, or rather the item at index 2, and you know, this is 0, this is 1, this is 2, that kind of thing. If this returned 5, it will put, you know, 0 1 2 3 4 5, it will put it in the 5th bucket.
Sorry.
Yeah, I'm waiting for the question.
Yeah, can you hear me?
I can hear you.
This is the code on line 75. The position of 0 that is returning 2.
Yeah.
Is it from the back?
Yes, from the back. If we said 1, it will return 5. If we say 2, it will return 2, this one. And if we said 3, it will return 7. If we say 4, it will return 0. So
Okay.
yeah. Anyway, I think with this you can find your way to create this function, right? Yeah, so what do you guys think about this, being able to create this?
Just can,
Can I do it?
just can you explain this line 73 again?
73.
Explain this line 73.
Okay, the get digits. Let me see. Let me add some more console logs. Let's say we're looking for these digits. How would I explain this now? Maybe 37. 37 divided by 10 will give you 3.7, right? So if you maybe let's put math.floor. So that we get a single something. So you notice how it's showing you 3. Let me add random digits.
Am I the only one? I'm not seeing what you're writing. Okay, I've seen it now.
You're seeing it now, okay. So if this is divided by 10, the last digit in what you get here will be this last digit, the digits, the second digit from the end, right? Okay, can you guys see this thing that I wrote? 10 raised to power 0 is 1. 10 raised to power 1 is 10. 10 raised to power 2 is 100. 10 raised to power 3 is 1000. Like that, like that, like that. So let's take this get digit for example. You know, if you write 0, you will get the last digit here, right? So this is why I'm dividing the number by math.power, like I'm raising 10 to whatever power of position. So if this is 0, it's like I'm dividing the number by 10 raised to power 0, which is 1. So let me try that. Let me use this to show you. If you divide by 10 raised to whatever power, the answer you would get, just be focusing on the last digit of this answer.
Which one?
No, the last digit of whatever you get from this division. You see the last digit is 3, right? This screen has frozen again. Can you guys see my screen? Like now you're seeing this stuff, right? 10 raised to power 0 is 1.
Yeah.
Yes.
Okay, that's cool. Okay, so yeah, look at this last, just be looking at the last digit from here. So now I'm dividing by 10 raised to power 0, 1, and the last digit here is 3. If I divide by 10 raised to power 1, which is 10, the last digit here will become 8. If I divide by 100, which is 10 raised to power 2, the last digit here becomes 7. If I divide by 1000, I get 3. Just, as always, keep focusing on the last digit. Something else. What's this one? 10,000, which is 10 raised to the power 4. I get this. 0, 1, 2, 3, 4. Like that. So now, if you pick any number, if you pick any number and let me see, 5, 6, 7, and you find the modulus, between that number and 10, you will get the last digit of that number, right? That's yeah. So if it's 6, you get 6. If it's, I don't know, 0, you get 0. That kind of thing. So the divide by 10 part is just to get the last number of whatever is here. This one is to sort of remove the unnecessary parts. So dividing by 10,000 removes all of this and leaves you with 37. Actually, you get 37.3, but the math.flow would remove the decimal places. Yeah. So if we divide by something that is too bigger than this number itself, it will be 0 point something something something, and math.flow will turn it to 0. So that's how this works. But again, if you have an alternative way of doing it, that's fine too. All win away, as long as you're not doing crazy things. Anyway, so how do you guys feel? Yeah, how do you guys feel about being able to write this function from the explanation and then from this pseudocode? I'll push this to GitHub so you can get the pseudocode there. Do you feel confident? Especially as you've seen it work, from beginning to end, you saw it work. Do you feel confident writing the code to do this?
Let's try.
Yeah, it's worth trying. I mean.
Can we do, if we do like for a smaller set, the code will still work for a longer one too.
Yeah, it's just okay. This one will only work for numbers anyway, so you just have to keep that in mind. But the rest of the other ones can be, like say, tweaked to suit your purposes. Yeah. So at least quick sorts and radix sorts, they are the easiest to write, to turn to code. Merge sort is weird and crazy, but these other two are very nice. Yeah, this one is a nice recursion. So in your recursion, you just pick array square bracket 0 as selected number, create two arrays left and right, loop through the array that you're given, check any number that is smaller than your selected value, you put it into the left array. Any number bigger than your selected value, you put it into the, or rather any number not smaller than your selected value, so that in case there's a situation like maybe there was a second 8 here, for example, 8 will also join and stay this side. But it's up to you, Sha. You could put it here, you could put it here. That's really up to you. So like that, you get a left array, right array, and then you just return this. you return quick sorts, like you return spreading of quick sort left array, comma your selected value, comma spreading of quick sort right array. So the recursion will just work its way down, and with the base case that is here, it will stop itself appropriately. The base case is that if the length of the array is less than 2, the array should just be returned like that. Remember how recursions are written now, so that one shouldn't be trouble. So honestly, I'm curious to see, I would like to see you guys try to write this from pseudocode. It will be a very big help to you, that you can see, a process being described to you, look at the pseudocode and come up with a function that does exactly what you're supposed to do. So I think we'll end here today, and once you come up with the formula, you can test it on something, it works. You can, present it to the group. It will be very nice. Right?
Alright.
Okay, so with this,
Yes.
we are done with the first. We're done with the DSA that we're doing right now. For what comes next would have been data structures, but mostly data structures, you need knowledge of classes to understand that, because there will just be classes everywhere in data structures. So we'll leave that one until later. So hopefully, I don't know, we've been stalling for time for the interviews to come, but I guess I'll talk to Ebuka again about the interviews, because that needs to happen before we move forward to like the intermediate section of this. The beginner section stopped at day 12, so it's supposed to continue day 13. I think some other things, console, how to use console, error catching, then classes, maybe JSON, promises. There are some other interesting things, sure. And then at the end of the whole thing, there will be DOM manipulation, which is, will I say, the thing that made people want to learn JavaScript. A lot of people, sure, like front-end devs. So that's that. So see you all later. Have fun.
Thank you.
Thanks. Thank you, sir.
You're welcome.
Thank you.
Yeah,
Please,
please.
can you share the link to the